In this video, I will focus mainly to explain what are the points need to be picked from the statistical analysis. So far we have done post experimentation by using any kind of a software, any kind of design of experiment or optimization related software, whatever the software it be. We are talking in a generalized way. Here, apart from that one, the topic will be like this: what are the points we need to be pick up, then how we have to simultaneously represent that one in the form of a research paper, because points pickup is not important. What are the points we need to explain in a detailed manner, that is also an important thing. So we will try to discuss in that particular manner also. So let me go into what are the things I will try to discuss it here. If you try to go this, basically we will try to conduct any kind of statistical analysis in the two categories, that is one is ANOVA analysis of variance, the other one will be some kind of Taguchi based gray relation analysis. Okay, I will discuss about the both the things, and remaining things and all, if it is a desirability function approach, you can try to interrupt the results, what are the things which are required. Okay, so in the ANOVA point of view, I will try to discuss about S/N ratios, how we are framing mean effects plots, percentage contribution of each factor, optimum condition levels, regression equations, and the graphs, some extra graphs. So in the Taguchi based gradation also, there will be some S/N ratio for the grades and normalizing the data, deviation sequence, gradation coefficient and rank, main effect plots, and optimum conditions on the parameter levels. So like this, with the help of prediction also in gradation analysis, we will try to plot like this. So this is a generalized procedure. Okay, if you refer any research paper, these things will be common things which we have to represent in a systematic manner. So if you success in representing these things in a systematic manner, and a proper explanation if you are giving to the researcher, then it is fine, because no need to give some other justifications, because your research is talking about data statistical analysis, mainly about this one. We have to give justification here itself. So let me go with the first category of ANOVA. What are the things we have to do it. For example, this is a sample table for ANOVA table. So in this ANOVA table, what are the crucial points which we need to identify was, you can able to see it here. See, from the analysis we will get degrees of freedom. From the analysis we will get degrees of freedom. Is it or not? So degrees of freedom. Next one is sum of the squares, mean sum of the squares, F value, P value. Up to this one only the table will be giving in any statistical software if you try to refer. But apart from that one, this contribution percentage also we need to be give. So this contribution percentage I have discussed in the previous videos, how we have to calculate this contribution percentages. So after calculating this contribution percentages, the model totally it is contributing 97.57 percentage. And among that one, cutting speed is going to have this much. Feed rate is the most influential factor here. Okay, 83.5%. That point we have to represent here. See, if you can see here, the most important factor affecting the quality of the surface finish is the feed rate, like this, because it is a more amount of percentage we are giving for the surface roughness. 83% means more percentage. Next, how much percentage contribution it has been given, we are showing that one. So 8 types of models, it is shown in the augmentation F generate furrows in the form of helicoids, means some technical aspect we have to give with respect to our procedure. Okay, why that is thing. And apart from that one, we will need to give some reference also, because this is playing a huge role, 83.5%. Why that is playing a crucial role, that is we have to give with some reference. This 18 is the reference which they have followed. From that reference they are concluding that feed rate is going to be increases, like that. And apart from that one, some other contributions also will be there. For example, here V square is influencing more, F square is also influencing more. Those things we have to explain. So that the two things are significant in nature. Is it or not? So significant means what? Here we will try to look that whether this value is less than 0.05 or not. So if this value is less than 0.5, we will mention it as significant. If this value is greater than 0.05, we will mention it as insignificant. Here if you try to observe, feed rate is significant, followed by cutting speed interaction and feed rate interactions are significant. those things we have to mention, and their contributions also we can mention. Okay, these are the things which we have to highlight in our paper, so that our statistical analysis explanation or justification will be satisfied. And this is for ANOVA table which I am discussing. Next one, I will go with one more similar ANOVA. This is for MRR. That is previously it is for surface roughness, and now this one is for material removal rate ANOVA. So here also some different contributions they will give it. If you observe, see how that material is going to be influenced. The amount of heat generation process increase with an increase in feed rate. That is what we have discussed in the okay. The cutting tool has to remove more amount of material from the workpiece. The workpiece plastic deformation is usually proportional to the amount of generated heat. This is a generalized statement, which it is a technically generalized statement. Okay, the technically generalized statement has been referred from some papers. Okay, so they are saying why this feed rate is going to be mostly influential for the surface roughness. Similarly here, if you see here, we have got 83.5%. I think this is also for surface roughness only. Okay, this is also for surface roughness only. Okay, not for MRR. So how this 83.5 is having a more influence, we have to say it in the form of technically. And because of the increased length of the contact between the tool and the workpiece, depth of cut has a smaller effect. Now if you can see here, the difference in the depth of cut very significant, not even 1%, not even less than 1%. So very small significant is there. So when we are trying to term some particular point is having high significance, then you can try to explain which is having low significance also. So this is having very low significance, like that you can explain. Okay, and again they will give one more justification. Based on the results, feed rate was found the most significant factor on surface roughness evaluation of this kind of a steel, like this. This is in good agreement with the previously published work. So they have referred around 4 papers. Among that 4 papers, maybe they have been worked with some different kind of steels, but feed rate has been influenced mostly onto that kind of machining process. So that is what their conclusion drawing. Okay, so that kind of justification is more important in all the research papers. So hardly it will take around 4 or 8 lines to complete this one. So that is the thing we have to extract. Apart from this one, here we will try to talk about this model is significant, terms are significant, these things and all common things which we will represent, and contributions also common thing which we are going to be represent in the research paper. But technical things and all, these things we have to conclude from the ANOVA analysis, right? I'll go to the next one. So percentage contribution. Again, so this is for some other output response. So for this output response, what they have done, this is for MRR, I think. This is for material removal rate. They have taken the output. Here, what are the significant parameters? Cutting speed is significant. Feed rate is significant. Depth of cut is significant. Almost all parameters are going to influence the material removal rate. Even the interreactions are also important here. These are the interreactions. These are also playing the crucial role in playing the significant. So that thing, it can be stated that depth of cut was the highest significance. So from here, if you can try to observe, depth of cut is playing a major role. Is it or not? First one, followed by feed rate, followed by cutting speed. So those things we have to mention it very clearly. Interreactions are not necessary for mentioning right now, because interreactions are having very less deviation. That's why. So 19.67% followed by cutting speed as. So interreactions right now it is not necessary. So those things we can mention it here. Cutting speed out, what level of contribution. So apart from that one, all the interreactions are also playing a crucial role and are found to be less significant. They are significant, but comparingly to these 3 parameters, they are found to be less significant. So that is the conclusion we have to give it from this category. Next one, signal to noise ratio. So here the signal to noise ratio, basically signal to noise ratio, this is for MRR, I think. This is for MRR. For MRR, we will try to choose the value for higher the better. So higher the better statistics, what we have to choose? The higher value. So the higher value here it is A at 4th level, that is A4. B parameter also at 4th level. B parameter at 4th level. C parameter at fourth level. So this is the optimal condition or the best condition for MRR for the S by N ratios. And here one more thing you have to one more thing many people are forgetting. You try to highlight the mean line also here. Okay, this red line is the mean line, as well as this one they have highlighted now with some round box, with some round blue color box. So like that you also highlight in your graphs, because that represent some statistical contribution has been given high preference here, like that. Because if you try to term like this here, if you try to see here, they have given A4, B4, C4 were the optimum combinations. But by seeing the graph without reading this parameter, I can able to just come to a conclusion that these three are the significant factors. So like that, some graphical visualization also you try to represent, it will be good. And here for RA they have given A1, B1, C1 are good parameters, and whatever the A1, B1 values, A1 at 120 meters per minute, feed rate at 0.08 mm per revolution, depth of cut at 0.1 mm was found to be significant, and optimum parameters for highest MRR also they have plotted. Is it or not? And at highest MRR, what are the parameters which are influencing? That is cutting speed at 280 mm, feed rate at 0.2, depth of cut at 0.6 are the influential parameters. So like that we can able to draw some inferences from the graphs which we are trying to be represented. Next, optimum condition levels. See this optimum condition levels, how we are trying to do. In the previous case we have mentioned, if you observe here 120, 80, 0.5, is it or not? The same things they are representing in the form of a table here. This is the thing they have got it from S by N ratio, S by N ratios, both the things. And the predicted value, predicted optimum value for that one is 0.45, and here it is 32. These two things are predicted, and with this particular thing they will conduct an experiment, and they found that 0.44. So surface roughness, it should be less value, so we have got decrease. Material removal rate, it should be greater value, we have got increase. So what is the percentage error? So percentage error, if it is in a positive value, then it indicates that these are the best optimal conditions, like whatever the prediction here it is correct. So that is what they have to represent. The percentage error between the experimental values and the predicted values of RA using S by N ratios are 2.27 and 3.35 respectively. The table 7 gives the predicted. Again, what this table is going to be give. Here they have applied mono objective. Mono objective is nothing but single objective optimization. Okay, as I am saying that ANOVA basically they will try to use it for single objective optimization. Okay, next, regression. So regression means what we are doing here, we are trying to go for modeling. Is it or not? Modeling of our output responses, we are going for modeling. So in this modeling, what we have to observe? So model basically talks about some kind of linear or non-linear regression. So what kind of regression they have taken? Here by seeing this one we can able to come to a conclusion that it is a non-linear. But here all the terms they did not used. We see this single terms they have to use, cutting speed, depth of cut, and feed rate. Apart from that one, VC interaction they have used, VC into F they have used, VC into AP they have used, F into F feed rate interaction they have used, feed rate into depth of cut interaction they have used, and depth of cut square also they have used. I think if you try to coin these terms, VC square, F square, AP square, all these terms are available. VC into F, VC into AP, this is there. Next F into AP, almost all terms are available here. Is it or not in this equation? Sometimes all these terms will not be available in these equations. At the time what this talks about, no, so they will try to remove the insignificant terms and they will try to frame the equation like this. Okay, but next, similarly for MRR also. So what is the conclusion they have to give here? For R square, coefficient of determination, which means that variation of the pub which is having for RA 97% and MRR 100%, which are very close to 1. As I have said in my previous videos that coefficient of determination should be very close to 1. So basically how this coefficient of determination will be identified means 1 divided by sum of means squares divided by sum of errors if that particular error is less than 0.95, then it is a good fit. If it is not less than 0.5 also, it is good fit, but we have to acceptably, and that is what they are saying, that suggesting a reasonable goodness of the model. That is what we have to mention in our papers. Okay, R square is good, so reasonable goodness of model is there. That is what we have to mention in our case. Next, graphs. So some extra graphs I have said, no, apart from the mean S by N ratio graph, this is one thing. So if you try to observe this one, basically we will do experiment for RA and MRR, is it or not? And we will develop some regression equation. In the regression equation, after the regression equation in the Minitab or any other statistical software, we will get fits or residuals, somewhere like residuals we will get, is it or not? So those things, RA experimental and RA fit, they will try to plot the graph. This here, the blue line represents the predicted one, whereas red represents the measured one, and you can able to give a conclusion like this. The predicted value subtracted from the second order model compared with the experimental errors between these values were plotted as shown here, and these figures have a little variation between the experimental and predicted values, very minimal variation. You can see the graph. Suppose if this predicted was somewhere here, then there is a large variation, but it is very close, so very minimal variation is there. So our model is very best fitted. Like this way also we can able to mention. Okay, so that is what about the statistical analysis, what we are inferring from the ANOVA. So next we will go for what are the statistical analysis when we conducted the Taguchi based gradation analysis. So in the Taguchi based gradation analysis, these are the data we will take basically. So first thing is we have to mention what is this GRA. So basically GRA is a tool which is used to convert optimization problem from a multi-objective to single objective, and try to mention some reference. And it is and here in this problem what we are doing, we are trying to simultaneously minimize the surface roughness and maximize the material removal rate. Okay, and this is the thing which we are going to study here. Like this we will give some conclusion, and then some formulas like step 1 for gradation grade, step 2 for deviation sequence, step 3 for gradation coefficient, step 4 for gradation grade. Like that we will give some sequence of steps. Okay, what this sequence of steps are going to be talk about also we can able to mention it. But here every time whenever we are trying to follow this formulas, we have to give some kind of a reference here. So this reference citation is known to you, I no need to explain. So next one, what are these normalized values in the form of a table? Here one thing we have to mention, that if we are not giving deviation sequence, at least you try to mention this ideal value. So this ideal value will be maximum of RA. 99.9% it will be 1 only. Okay, because maximum value of this entire normalized data will be 1 only, no, as we have discussed in the gradation analysis theory part and all. Okay, so don't forget to mention this table, this line in your table whenever you are representing the normalized graph. Suppose if you are representing the deviation sequence, then no need to represent this one, because deviation sequence means what? 1 minus that original value. Suppose here it is for fifth experiment 0.90, this will be the deviation sequence, so then no need to mention this one. But if you are not mentioning the deviation sequence in your table, normalized only, you mention this one, it will be good perspective. Next, gradation coefficients also we are mentioning. After gradation coefficients we will go for gradation rank. Sometimes if it is a Taguchi, definitely we have to mention the S by N ratio for the grade also, S by N ratio for the grade, and then go for ranking the grades. So here if I try to rank the grades, it will get 13th as a best. If I try to rank to this S by N ratios, higher the better, then also I will get this one only. Okay, so 13th experiment is the best experiment. Some authors, they will try to highlight this one also, like they will go for giving this one as bold, okay, or highlight with some other star mark like that. Okay, it is better to give. And here you have to write some input, like what is the gradation ordering, how we have to take, and the highest gradation cases are in the order of 0 to in the order from the 1, like from descending to like from lower value, that from rank 1 to rank 16, like that you have to explain. And from here they have got that 13th experiment was the optimal factor setting for the minimum surface roughness and maximum material rate. That is what their objective they will again mention it here like this. Next, S/N ratio for GRA. So here after calculating this one, they will have for the grade, whatever the grade which they have got here, for this grade they will try to calculate, or for this grade they have calculated S/N ratio. No? This S/N ratio they will plot it as a mean S/N ratio, and from mean S/N ratio they will try to conclude one thing: A4, B4, B1, C4 are the optimal parameters they have predicted. So that is what they will give here. So A1, B1, C4 are the best combination values, and they will say that the best combination values for the maximum multiple response character was this one. ANOVA results has been shown this one, and these are the things which we have calculated from the gray relation analysis. From the gray relation also again they will go for gray relation ANOVA for gray relation table also. From the ANOVA gray relation table also, which are the factors are most influencing, like that here you can see ANOVA results are tabulated in table 11, and from the table 11 at a level of 95% coefficient, these are the most influential parameters, like that they will mention it. Okay, it is a better practice to mention for ANOVA also. ANOVA for GRA, that is what I am showing. Okay, here if you try to observe, here they have keep only significant terms. Okay, and here you can observe here VC, F, depth of cut, VC into AP. These are some kind of interaction terms which are having more to influence on this particular model. Like that they will mention, and you have to give some explanation also why. Okay. The error between the experimental, this is a different one. Okay, this is I will discuss in the next one. Okay, next slide. But this table is for ANOVA. This table we have to explain. In the previous slide I have explained the theory of that one. Next, summary. So summary means some kind of a conclusions. So what this table is talking about means they are talking about the experimental values and predicted values. See here, if you can see here. So here what is the predicted optimal? Predicted optimal for ARIA we have got 0.3. For MRR we have got 13,453. And experimental value we have got decreased in the surface roughness, increased in the here also it is decreased. So here the error is very small, but here the surface roughness has been improved a lot. 3% surface roughness has been improved. So that is what we have to write it in the calculation. The error between the experimental values and the predicted values for RA and MRR using GRA are 3.27 and 0.1% respectively. Okay. Therefore, using GRA, process parameters can be successfully optimized for multi-response of so and so steel. Okay. So like that they have to give some conclusion. So that fetches their summary, and this summary is talking about what they have applied, Taguchi they have applied, RA and MRR are their output parameters which they have estimated. The percentage error between the experimental values and the predictor are less than both 4% for both machining characteristics. So like that they will give first for single objective, then for multi objective, then they will summarize this paper. And this paper is published in a very good journal. I have taken from International Journal for Advanced Manufacturing and Technology, one very good journal in the field of machining sciences. Okay. And the last one is we have to conclude. So far we have done single objective and multi objective, right? So those two things we have to get conclude. So in the form of a summary of comparison of the table, like in the single objective by using the Taguchi method, these are the optimal parametric combination, and these are the RA and MRR values. We have to mention it. Similarly, when we are going for multi objective, these are the values which we have got. So what is the improvement? Because when we are going for multi objective, what is the change? When we are going for the single optimization, what is the change? So those things we have to get a conclusion like this, and here we can conclude in such a way that what we have done it in single object optimization, what are the cutting speed and depth of cut have influence on RA, whereas rise in feed rate increases in RA, and what are the optimal values for MRR found to be cutting, and multi-objective results were obtained by using which technique. Here they have applied gray relation and minimizing the surface roughness, material removal rate, feed rate, percentage error. All these things we have to give some brief explanation. After giving this brief explanation, then we can able to conclude the part. So this is also one of the procedure to adapt to write a papers like this. Thank you.